Come light it up, I'm ready to go. Come light it up, come light it up, I'm ready to go. Come light it up.
Thank you, Monica. How's the audio quality?
It's fantastic.
Okay, I appreciate everybody's time. I know it's valuable these days. Jorge and I hope to, let's see, let's go to the slide section. And I'm ready to take over the slides. Let's see here. Okay, so Jorge and I, we work at Lockheed Martin. I'm a tech fellow, data architect in the intelligent factory realm. Jorge is the data product owner. And what I want the audience to take away today is I'm going to be demoing the pipeline, and I'm going to be demoing how our objects that we're connecting generate the data that goes into Starburst Trino. And then Jorge will take over and illustrate the value proposition for what use cases we actually support using Starburst. And I don't want to bury the lead, but there's some good ones out there. And so over the next 20, 25 minutes, I think I'll take you through a couple of slides that, because this is a technical external audience, we may not have much familiarity with Lockheed Martin itself. So I've got a couple slides that will introduce our business and who we are and kind of what we're about and who we support and our missions and some of the business units that underlie the single ticker symbol, LMT. And then I'll take you through some of the operational reference architecture. So that is to say, some of our industrial machines out on the shop floor in a manufacturing environment, we're connecting those to a cybersecure fabric. And I'll go over a little bit about how we connect the machines and how we translate the data into a common ontology, common format. And then Jorge will take over and tell you a little bit about the challenges, the data pipeline, and a lot about Starburst itself. So I wanted to play a little 1-minute video here that says so much more than I could about Lockheed Martin and illustrates some of our customers and our people, who I think is our greatest asset is our people. So if we could play that.
We are at the service of those who serve.
The brave ones who put their lives on the line for all.
For them, our mission is to always stay ahead.
To outthink,
outdo, and outlast. Not just with might, but with mind.
Not just with power, but with purpose.
We are pioneers,
innovators,
thought leaders, and threat readers.
champions of science,
technology,
and progress.
We are more than 100,000 strong.
Multicultural,
Multinational,
and multidimensional.
Serving every domain.
In every part of the world, for everyone. We are Lockheed Martin.
We are Lockheed Martin.
We are Lockheed Martin.
And we ensure those we serve always stay
Ahead of ready.
Okay, thank you for that. We really are a multinational company. We have business units in 345 facilities all across the world, 54 different countries, which is, I think, more than a quarter of the total countries out there. And out of the 120,000 employees, you'll notice that about half, almost 50%, are engineers, scientists, and technologists. So we really are a technology company. Okay, how is Lockheed Martin divided up? It really is 4 unique business areas. So aeronautics line of business there on the right is the area that I've been focused most of my career on. You may have heard of the F-35, the F-22, the P-3, the U-2, Skunk Works out in Palmdale, Kelly Johnson's crew. We also have missiles and fire control, primarily based in Texas and Orlando. Rotor and mission systems, if you're familiar with the Sikorsky line of business, the Black Hawk, the CH-53K heavy lift, We have a lot of commercial line of business there too, as well as military. And then our space division in Colorado, you may have heard of the Orion program and some of the satellites that are being launched through the ULA and our partner SpaceX in that division. So really 4 unique business units. But one thing I'll note on this slide is the pipeline that Jorge and I will discuss supports all 4 business units, the entire enterprise. So we've connected over 1,000 machines in all those facilities across the world that we mentioned earlier to deliver telemetry data and file transfer, secure file transfer from all of these units into a secure fabric. So that's a good segue to lead into the data really is what delivers the value. And through our Starburst Trino products, it is a key enabler for that intelligent factory of the future that we're building at this very moment. So how do we do it? And what types of machines are we connecting? This is not a comprehensive list, but I did pick 3 that I feel are fairly representative of what we're connecting. You see in the top left, we've got an F-35 wing drill. I think it's a Cincinnati or a Phoebus. We've got autoclaves, which are essentially giant ovens that cure the parts under temperature and pressure. We do have the paint robots that spray the low observable coating, the stealth coating on the exterior of the aircraft that absorbs the radar. So these machines generate telemetry data like rotary axis speed, execution state of the machine. What is the machine actually doing right now? Is it milling? Is it drilling? Temperature, pressure, things like that. And we can actually unlock use cases like anomaly detection, causal analytics for scrap rework and repair reduction. But I will note that the data coming off these disparate machines, each OEM has their own native data language. So how do we create what I call a Google Translate for machine language? How do we translate that vocabulary into a common framework? Well, the way that we have chosen is an ANSI standard called MT Connect, which is essentially provides a common vocabulary for all the machine telemetry fields coming off the machine. So we install a piece of software called an adapter somewhere close to the machine. It may be on the controller, it may be on a industrial PC close to the machine, but somewhere for latency purposes on the shop floor close to the machine. And that adapter takes that native OEM language and converts it to a common language so that no matter how many different machine asset classes we connect, they're all speaking the same language. And we can format that into a JSON structure. And our JSON structure provides a way to load very, very seamlessly in low latency common format into Starburst, into our data lake in the GovCloud. You don't have to use JSON. You can use XML or some other structured format. We chose JSON because it's a lightweight. It translates into MQTT for brokering, and that has provided tremendous low latency value for us. So with that, I'll probably turn it over to Jorge to let you know a little bit about the Starburst specific aspects, now that we know how the data is generated and the common ontology for the different use cases and how our customers are using the data.
For our presentation, we're going to cover how our pipeline was built and why did we pick Trino and how Trino help us covering all the use cases that we have at Lockheed. So first, what were the challenges that we encountered when we came across this project? So first, Lockheed Martin has multiple lines of business, as you have seen before in previous slides, and that makes our job more complex because there is a large diversity of devices that we need to accommodate. So there is a wide landscape of manufacturing equipment we deal with basically, and that's very diverse. So the IoT devices that we connect across the corporation have different protocols, different standards. So that's the first challenge. Data is, on the second hand, created at an unprecedented scale. So the volumes of data that we're collecting today are hard to manage if you don't use the proper tool for that. So vast amount of data collected every second from all these devices becomes cumbersome, and also as you include new devices, your data may change over time. So all those are items that we took into account when developed and selected the tools for our pipelines. Along with that, scalability, storage, accessibility, having some data layer that you can query with good performance to feed dashboards and support artificial intelligence, machine learning, data discovery, forensics when we need to do forensics. So, needless to say, there are transformation, governance, and security are crucial for our business. So, all these were challenges that we encountered when we design our pipeline. So, first, to overcome the issue of having a diverse set of devices, so we decided to embrace the MT-Connect ANSI standard. That's a framework that provides and documents a single protocol structure that you follow, and you can move data in JSON format with a standardized structure. And if we conform every device that we have to that MT-Connect standard, then that eases on the maintenance and changes over time, and on the pipeline design as well, because now you design a pipeline to conform to this standard and not the variations that you find in all the devices across the corporation. So this is a robust standard that is robust enough to handle all different type of classes, and all our Lockheed Martin business units uses our IFF data because of this. So the diagram shows a breakdown of devices, the components for those devices, and in the lower layer here, in the lower part of the diagram, you see that everything becomes a data item, and that was a design decision. So we basically write all our data into a single standardized physical format. And this physical format have data items and data types and attributes that describes the actual item being measured. And we collect not only observations, but we also collect events, conditions for the devices that help later on for deriving utilization dashboards and such. So here is an example, because we are collecting all devices in one simple standard, in one common data model. So we have designed Grafana dashboards to reverse engineer a little bit what is on production. So if a user, if a consumer goes to our production data layer, so they can come here and they can see all the type of machines that we're collecting from, the category of items being collected, the data item name, the data item type, and they can drill down into this and go one layer further to find out for a specific device what are the actual parameters being measured. So this was a dynamic way to compensate what would have been a rigid data model, because this gives you real-time connecting to the actual data and displays to you what is there for you to query. So this next slide, so pretty much deals with volume, just to show you the volume of data that our different business units collect. We are in the terabytes right now, 100 plus terabytes we have on the data lake today. We are not collecting from all the manufacturing sites. This is an ongoing process, but we have deployed more than 60%. And you can see I took an example for a single business area. So just one day of collection goes between 50 and 70 gigabytes of data, depending on the day. It fluctuates, but that's daily, and it's catching up pretty quick. As we add more devices, this is going to increase. And using Trino handles this data graciously. So this next slide is okay. How do we approach the design? What we have done to implement the infrastructure that enable us to divide and conquer this ingestion of so many IoT devices. So basically, it's a step approach. On the left, so we can see the physically connecting manufacturing equipment, the applications, machines, devices, tools. So all this needs to be conformed to that MT Connect, so it can be placed into our pipeline for ingestion. And that's what it does. The second box there, the Intelligent Factory Gateway. So it's a sort of a translation layer there, and that standardizes the rest of the pipeline. Now we can have a second step of the pipeline, which is basically how do we ingest all that data coming from all devices from all sites, standardized to the MT Connect standard. So basically we created a data pipeline using serverless architecture, AWS, and having the serverless architecture allows us to scale up when the through output needs to be higher. So that fitted our desire to create this dynamic pipeline, and putting the output in S3, it works really well with Trino, and now we can have Trino users consuming all this data using SQL statements. So the flexibility that Trino gives us here is incredibly important, because we can consume any files that we place on S3, being that ORC, Parquet files, or even Avro files coming from an ETL, from all the data flows as well, that we stored these along with the device observations from MT Connect standard that we just mentioned. And Trino is capable to consume all of those and to present that as a data layer for users to use those in analytics dashboards, data science projects, anomaly detection, etc. So it's a very useful platform that allows users to connect in many different ways. One last thing I'd like to mention is that our IoT pipeline is not only conformed by MT Connect data, it has other moving parts of when people think of IoT, and I'm going to go to the next slide with this. When people think of IoT, they think of device observation like temperature measurement or rotation speed or things like that, but IoT is much more than that. We collect the MT Connect pipeline, which was the one that I was showing earlier, but we also connect data to smart tools like torque wrenches and drills that put data on the pipe to test results. You need to test the products that you create. You need to test also the equipment. So there are applications out there that give us test results, and we grab those test results, put it in JSON files, and then we are able to consume that using Trino. Calibration data, all these devices need to be calibrated, and that's part of our IoT landscape. Inspection results, the visual inspection of things that have been created or produced. So these are all images and third-party tools that, again, we put the data into the data lake, and it's ready for consumption for AI ML workloads, etc. Material location tells us where items are for a given factory. Surface mount technology give you quality on the surface board, what equipments are failing, so we're collecting that data. And finally, our device list, which we need to track because of the diverse ecosystem of devices that we have. We have created an in-house application to drive that, to inventory that list, to keep track of those. And so we keep track of that and expose that through the data lake as well. So we use Trino everywhere, pretty much, as you can see. And on the last slide, I want to cover why we picked Trino and how Trino supports everything that we do. So basically, the high performance, it's an optimized SQL engine for large data sets. So that's crucial for us. You saw the volumes of data we deal with. So that's a must-have. Supporting historical and near real-time analysis, that's key. That goes hand in hand with the high performance too. Trino provides us with the mechanisms that help us query using SQL and analyze data that is close to real time, which is crucial for IoT application, where the timely insights can make a significant difference. Scalability and reliability, as the IoT ecosystem grows, so does the data. So Trino allows us to easily scale out by adding nodes to the Trino cluster. accommodating the ever-increasing data volumes that, these days we encounter over and over, and all this without compromising performance. The flexibility that Trino gives us, supporting a wide range of data sources, it makes it ideal to be able to adapt to the multiple use cases we encountered. Like you saw in previous slides, we not only collect device observations, we collect data from APIs, other databases, and such. So having that flexibility is key for us. And one last thing, the seamless integration, allowing for the construction of our data lake house by integrating with systems like Apache Iceberg, or by integrating with tools like data virtualization tools that allows you to have a virtual layer on top of Trino. That's also a key decision point for us. And all these along make Trino the ideal tool for us, and we use it extensively in our pipeline. Thank you for listening.
Oh my goodness. Thank you, Brian, and thank you, Jorge, for that fantastic presentation. Brian, I have a couple of notes here that I really thought were interesting, specifically when you were talking about your OEM native language and the common framework that you have to build. I thought that was so similar to like the Trino service provider interface that we built for all our different connectors. And so I thought that was really interesting to kind of, compare that kind of what you guys are doing over there with what Trino has built as well.
Very similar, yeah. You start with disparate inputs and you map them into a common output. And so there's some similarities there for sure.
Yeah. And then I also thought a lot about, the ending slide, just like very impactful to kind of all the themes that we've been talking about today, what Jorge mentioned about like the flexibility, the scalability, reliability, the high performance, like really the whole point of, Trino in general. I just thought it was extremely interesting to hear, how all the points we've been trying to hammer in on are just being completely reflected in Lockheed's data environment.
Yeah, if we had more time, we could go through all those other use cases, but we had to pick one, for time purposes. So hopefully it was illustrative of how we use Starburst products to deliver value. Hopefully that message was implemented or came across.
Absolutely. I got my first note. Pipeline supports all 4 business units, over 1,000 machines, which is just incredible scaling wise.
Yeah, we hope to get over 2,000 within the next 18 months. We're right in the middle of migrating all the machines to a cyber secure network.
Awesome. That's a great thing to hear.